This is going to be our lesson for 2.04 over chords and arcs part 2. By the end of the class, we want you to be able to work with the relationship, identify and use the relationship between the measure of an inscribed angle and the measure of an intercepted arc to solve problems. Now, in light of that fact, I'm going to go ahead and jump right into the new concepts today rather than going through the review of the old concepts. You can review these in the slides, the completed slides, which involve your arc review concepts, semicircle, minor arc, major arcs, and your central angle review concepts as well. Today, however, we're going to start looking at the inscribed angle. Now, the inscribed angle is an angle that has a vertex that actually lies on a circle as opposed to at the center of the circle. And you'll also notice as well that the sides of an inscribed angle happen to be chords in the circle. So the example that they give is angle VXY, which is an inscribed angle. So that's how we define an inscribed angle in our case, right? The sides are chords of the circle and the vertex is on the circle. So there's 3 different cases of inscribed angles that you can refer to. One of the cases is where the center of the circle lies on a side of the inscribed angle. So right here, the center is on one of the sides of the inscribed angle. Case number 2, actually, after case number 1, is the center is actually inside. So it's in the interior of the angle. And then in this case, you have one that's on the outside of the angle. So like here's the interior of the angle, and it's on the outside. So it's on, inside, outside, basically are the 3 cases that you're going to encounter. That doesn't actually change the rule of what it does though. So on top of an inscribed angle, you have to also define what we call an intercepted arc, and we're demonstrating that in this case right here with the arc AD. So an intercepted arc is an arc that is opposite an inscribed angle. Okay, so you've got the angle right there, and the arc opposite that is arc AD. Okay, now angle AED is the inscribed angle itself, and the arc AD is the intercepted arc of that inscribed angle. And the endpoints of that arc AD are A and D. This is the most important relationship today that you can follow. This inscribed angle, and I'm going to write inscribed here, the inscribed angle is equal to half of the intercepted arc. Half of the intercepted arc. Okay, so remember, the other thing that you could also say as well is that the intercepted arc, so intercepted arc is equal to 2 times the inscribed angle. 2 times the inscribed angle. That's the same relationship that we could rely on. So either relationship will work in our case. So let's take a look at an example. We're going to calculate the inscribed angle x, and we know that it's equal to half of the intercepted arc. Okay, so identifying that this is the inscribed angle x, and this is the intercepted arc of 100 degrees right here. Okay, so with that being said, we're looking for the inscribed angle, and we are given the intercepted arc. So the value of x is going to equal 1/2 of 100 degrees. That means the inscribed angle is going to be 50 degrees. Easy, right? It's just half of the intercepted arc that we have there. So that is going to be a 50-degree angle as a result of that relationship. Now you could pause the video and see if you can come up with the answer here as well, and see if you can arrive at the result that you're supposed to get. In this problem, they are asking for the measure of the intercepted arc, so we're actually looking for this, and they gave us the inscribed angle. So there's several ways to think about that, but remember, the intercepted arc is equal to 2 times the inscribed angle, right? So if we have an inscribed angle of, and we'll go ahead and call this x, I guess, since that's what they call the intercepted arc, and they gave us an inscribed angle of 64 degrees, then we should say 128 degrees for our intercepted arc. So the intercepted arc measure is 128 degrees, which is double the inscribed angle. Okay, so 128 degrees should be the answer you selected. Now let's take a look at another example here. So there's actually quite a bit of things that are happening here, and I just want to point out a few things. AE and BD are identified as diameters of the problem, so I'm going to highlight that. So AE is a diameter and BD is a diameter of the circle. Those are chords as well, by the way. We are tasked with finding the measure of ADB. I'm going to use red here to emphasize that that is this angle right here. Okay. Now, what we should recognize in the figure, number one, is we want to go ahead and we want to figure out what the measure of the arc ED is. So I'm highlighting this in orange. I'm going to find the measure of arc ED. So find the measure of arc ED first. And again, that's easy, right? The measure of the arc ED is going to equal 2 times the inscribed angle. You'll notice the inscribed angle for that particular arc is actually 42 degrees. So we end up with 84 degrees there for this measure. I'll write that right here. 84 degrees. See the relationship? The inscribed angle 42, and then we have 84 right there. Okay. Number two, what we can do is we can also find the measure of the arc BE. So the measure of the arc BE, I'll highlight that in yellow, is right here. Okay. Now, when you're looking at that particular arc, the way that that works is I want you to focus on this is a semicircle. So, if that is a semicircle, that means I can find the measure of arc BE by simply taking 180 degrees and subtracting from 180 the 84 degree angle. That's going to get me 96 degrees. So this is now a 96 degree measured arc. Then number three. For number three here, we're going to find the measure of the arc BA. The measure of the arc BA. So to find the measure of the arc BA, look at the fact that this forms a semicircle. If that forms a semicircle, then in order to find the measure of the arc BA, I can take 180 degrees and subtract 96 degrees. Now we know that that equals 84 degrees. So because I have that other arc measure now, which by the way, this is the most important one of all. Why? Because it's the intercepted arc to this inscribed angle down here. I can now find my answer, number 4. I'll just go ahead and call it x because that's what I called it. X is going to equal 1/2 of 84 degrees. That means all along, taking you through that pathway, that intercepted or that inscribed angle was actually also 42 degrees. There are other ways to verify that and prove it as well. However, for the time being, I just wanted to point out to you that with that being said, this was certainly one way that you could go about relating inscribed angles and intercepted arcs and working with them to figure out what your answer is going to be, okay? So maybe what you could do is pause the video and try finding the value of x here yourself. This one actually doesn't take as long for you to do. So on this particular problem right here, I noticed that this is a right triangle, okay? If that is a right triangle, then this angle has to be 64 degrees. Why does that have to be 64 degrees? The reason it has to be 64 is because all three angles have to add up to 180. But also, these two angles have to add up to 90. So if you took 26 away from 90, you would get 64 degrees. Why do I care about that angle? The reason I care about that angle being 64 degrees is because notice it intercepts this arc. That means that this measure here is going to be equal to 64 because it also intercepts this arc. The two inscribed angles located at angle B and angle A inscribe, or rather intercept, the same arc. That means they both are going to be 64 degrees. The answer is 64. Yes, this intercepted arc is double 64. That's fine. But remember, when you have two inscribed angles, in this case, this angle here and this angle here, they both intercept the same arc. That means that they are going to be the same exact value. They are both going to be 64 degrees. So that was a very quick and easy answer to find in our problem case. So let's take a look at this example. We need to figure out the measure of arc AB. Okay, now there's a lot of stuff that we can write down and everything, and that's all fine and whatnot, okay? But it's, in simplest terms, what I want you to focus on is notice the inscribed angles rather. You see how they have the same exact arc marks? These angles are actually equal to each other, okay? So in simplest terms, you have two equal, or you can think of them as congruent, inscribed angles. So the two inscribed angles are in fact the same measure. What does that tell me? It tells me that the measure of the arc AB has to equal the measure of the arc DE. Therefore, the measure of the missing arc AB also must be 50 degrees. Okay, so if you have two intercepted arcs that have congruent inscribed angles, then of course the arcs themselves will also be the same. That's the relationship you can pull away from that. So here's one you could pause and you can try this one yourself. So here you're looking for the measure of arc MN. Okay, well, looking at the diagram, that seems fairly straightforward because they told me that they're looking for this particular arc, and it is in fact this angle that is inscribed. So the measure of the arc MN has to equal twice the inscribed angle value. That means that we should select 70 degrees for our answer to that arc measure. Okay, it's double the inscribed angle. So in this problem here, we're now going to look for the measure of arc LN. We're looking for the measure of the arc LN. I'm going to highlight that. LN is right here. That is this entire arc. So there's quite a bit going on with the diagram here, okay? But I am aware of what we need to do, because the first thing I'm looking at is I'm noticing they gave me an arc measure of 92. Now, that means I can find this angle that I have highlighted in orange, okay? And for our purposes, you can name them whatever you want, but I know that the angle that they've referenced there is angle LNP, and I know it is equal to half of the arc, the measure of the arc LP. So that means I'm taking half of 92 degrees, and that's going to be 46 degrees. So that degree value is 46. Pay attention to the screen now. This is a triangle. I have two angles in that triangle that I now know and one that I do not. So the angle I am most interested in is the angle LPN. The measure of the angle LPN is going to equal 180 degrees minus the other two angle values, in the diagram, 68 and 46. 180 minus 68 minus 46. And in that case, we end up with 66 degrees. Why is this angle so important? Because it matches with the intercepted arc. It's the inscribed angle to that arc. So, if I want to find the measure of the arc LN, the measure of the arc LN is going to equal 2 times 66 degrees. That gets us 132 degrees for the measure of the arc LN. That's how I can find it. So notice that I had to use my rule for the triangle sum theorem in this second step right here. Right? If I broke it down into steps, I used the triangle sum theorem to find the third angle in the triangle, and the third angle happens to be the inscribed angle I needed to find the corresponding intercepted arc that it creates. Okay? So then that's connective relationships that you're working with on that. So you can pause the video and try this one yourself as well. You are looking for the measure of the arc AC. That's this arc right here. They tell you the angle ABC is 35 degrees. Okay, so right away we should see that the measure of the arc AC is equal to 2 times the inscribed angle value. So that means you should say 70 degrees for your answer there, okay? That also means this is 35 degrees as well, by the way, because they intercept the same arc. Okay, and with that, you have your exit ticket. So on your exit ticket, you are tasked with finding the arc measure of AB. That's this entire arc right here. So the advice I'm going to give you is think about how you could maybe add these together, right? And remember the relationship. The inscribed angle is half of the measure of the arc that it intercepts, all right? You're looking directly for the measure of arc CE here given the inscribed angle 45. So that's the direct relationship right there. Remember, inscribed angle is half the measure of the intercepted arc. And then lastly, given this diagram, assuming the side lengths and angles are drawn to scale, given C with diameter BD, find the angle ADB. Okay, so you're finding this angle down here. One thing that I would recommend that you think about is think about how this forms a semicircle. How could you use the total degree value to determine the missing degree value that you see right here? Knowing that this forms a semicircle entirely, how could I then find this degree value? And remember, this degree is supposed to be half of that, right? Because it's an inscribed angle. And that's going to represent your lesson for 2.04 rather, for chords and arcs 2.